The OCI Designer Toolkit, OKIT, is a tool developed by Oracle that simplifies the design, visualization, and management of Oracle Cloud Infrastructure environment. It's available as an open source project on GitHub. OKIT provides a browser-based drag-and-drop user interface for designing OCI architectures. It can generate Terraform script directly from the graphical designs. It can integrate with version control system, for example, Git. And we can use the generated script to provision resources on PCA. With OKIT, you gain powerful tools to introspect Oracle PCA. These features allow you to query existing resources within a tenancy or compartment as shown on the left side of the slide, where instances and their status are listed. OKIT automatically generates clear visualization like the architecture diagram on the right. This means you can take an existing infrastructure setup, analyze it, and then visualize the architecture directly in OKIT. Whether you are managing a small environment or a large complex one, OKIT can help you document, optimize, and streamline your OCI architecture efficiently. Let's start the demonstration. On this PCA environment, I have already provisioned a compartment called OKIT Demo, and I will provision the resource on that compartment. To start OKIT, you have to go to the browser and point to OKIT. When the browser starts, you can see that there's three types of an option for you to choose. And in this case, I will do the demonstration of OKIT with PCA. So I choose the OKIT Designer for Oracle PCA. Then OKIT will load the user interface, which is the browser-based user interface. On the left-hand side, you can see palette-like interface that you can choose the OCI component on the left, and on the right-hand side is like a canvas that you can do the drawing. What you can do in OKIT is design the infrastructure. On PCA, the first infrastructure that we normally provision is VCN. And you can drag the VCN and then drop here. And you can see that in this construct, they're gonna have default route table, security list, and the SCP option. Yeah, and you can drop more component onto it. For example, you can drop subnet. You can create routing. Maybe you tell them that you would like to use this existing route table and this security list and this DSCP option. And you can create more things like VM, the internet gateway. You can set the router, route rules to route network to the internet gateway, for example. So everything can be configured. And after you finish the design, what you can do is you can generate the Terraform script. On the left-hand side, I can change the view from the designer view to Terraform view. And here are the Terraform script that automatically generate from your design. I have designed a VCN with few cloud resources, which I will demonstrate how to deploy it to PCA using Terraform. Let me open it in OKIT. The design is saved in JSON format. You can see that from this design, what I will create is a VCN. The VCN name is OKIT test. And there is one internet gateway in this VCN. The CIDR block for this VCN is 10.0.0.0/16. And there is one public subnet in this VCN, which is SM public using CIDR block 0/24. A route table for this subnet route any IP to internet gateway. There's a security list, and mainly it allows SSH, which is port 22, into this subnet. VM1 is a compute instance, and its primary VNIC attached to subnet SN public. We have VV1, which is the block volume, and this block volume will attach to compute instance VM1. MT is a mount target in subnet SN public. We use this mount target as a mounting point for file storage services, exporting file system services, FS1. Let me show you how you can use Terraform to deploy this infrastructure. First, you open the terminal. In this post, I have already created a directory called OKIT test. Okay. All the files in OKIT are actually generated and saved in this directory. What I will do is that I will copy all the files from that OKIT directory to this directory. Here are the files. You can see that majority of them are Terraform script, and there's one special file called terraform.tf_var. If you take a look into that file, you can see that there's a number of parameters that we have to fill before we can run. I have already got this terraform.tf_var field. I just copy into this directory what is in this terraform.tf_var. I just fill in the blank all the information they require to run Terraform, like tenancy, OCI ID, user ID, fingerprint, private key path for the key, and the region and component ID. Then we are ready to run Terraform. The first step to start Terraform, you have to run Terraform init. Then Terraform will talk to the internet and pull the necessary provider plugin. And the provider plugin that we use here is OCI provider plugin. Then we can run Terraform plan to see what it's gonna do if this script is run. You can see that there's a number of the green plus sign here means that these are the resources that it will create running this script. Before you can run Terraform script, one parameter that you have to set is this. Let me show you. Okay, you have to export custom search location, which is the environment variable, to point to the CA search bundle of PCA. Otherwise, you cannot run Terraform correctly. Let's run Terraform apply to provision all the resources. Terraform asks for confirmation. I just yes, and then after press, what Terraform will do is it will talk to PCA OCI backend and provision all the resources. You can see that it will create all the necessary resources as we design. If you look into the log, you can see that it creates volume, it creates file storage services, it creates VCN. Okay, sometimes it's still waiting to create resources because some resources take some time to create. Now all the resources are provisioned. Let's go back to OKIT and check if the resources is provisioned. We can use a function in OKIT called query PCA. Tell them which compartment you would like to check and then click query. And now you can see OKIT demo compartment and you see that we have resources provision onto this compartment. We can confirm also using CEUI. You can see this is instant view. We have VM1 running on in OKIT demo compartment. If we take a look at VCN, yes, OKIT test is here. If we look inside, You can see there's subnet, they have a route table, internet gateway, everything has been provisioned as designed. Or even block volume. If you go to block volume, you can see BB1 file storage services, SFS1 provision, mount target, MT1 is provision, and here is the IP address of the mount target that we can use to mount the file system. Yeah, overall, all the resources are provisioned as we design, and this concludes this demonstration. Thank you.